So homework 11. A bunch of word problems. Hopefully they're ones that you already saw if you took introductory algebra, so it'll just kind of be a review of stuff. First one is finding the new score that will yield a given mean. The mean is a fancy word for the average. When you find the average of something, you add all your numbers together and then you divide by how many numbers you have. On Alex, they're probably going to give you some big crazy long formula, but basically what you want to do is you want to take what you want the average to be, and the first one says we want his average to be 79. That means it'd be like if he got a 79 on every single test he took. So if I have taken 4 tests and I'm going to take another test, I'm going to take a total of 5 tests. I want my average to be 79, so it's like I got a 79 on all 5 of my tests. So the first thing I'm going to do is figure out how many total points I'd have to have an average of 79 in all of my tests. If you take 79 times 5 for me, you would get 395. Then basically all you're going to do is subtract off the ones that he already did. On Alex, they're going to add them first and just subtract one big number, but since you're using your calculator, you might as well just go ahead and subtract the 99, subtract the 71, subtract the 58, and subtract the 73. At the end then, you should have what the last test has to be. $94. So he has to get a 94 on his last test so that his average is 79 to make up for that really bad 58 he got. So the second one there, Frank has scored a 28, 21, 20, 26, and 22 points in his 5 basketball games so far. How many points does he need to score in his next game so that his average or mean is 24 points a game? So again, if my average is going to be 24, it's like I have 24 points on every game. He's played 5 games so far, but he's going to play a 6th one because he's going to play one more. So if you multiply 24 by 6, you would get 144. So we'd have to have a total of 144 points to have an average of 24 points on all 6 games. He's already scored some points, so we're going to subtract off the 28, subtract off 19, subtract off 20, subtract off 26, and subtract off 22. Or add them all up and subtract them all at one time. 29. He needs to get a 29 points in his last game, so his average is 24. So go ahead, do number 3 there. I'm not that far yet. Danette says she got 60. Started out with 59 miles per day is what they want the average to be. They're doing a 6-day cross-country biking challenge. And so if we take 59 times 6, we get 354 total miles, I guess we're doing here. So if I subtract off 60, subtract off 60, subtract off 55, another 55, and my 64, which I haven't done yet. Minus 60, minus 55, minus 55, minus 64. Sure enough, I get 60. So 60 miles is how far she has to go on that last day so that her average is 59. Number Number 4 says finding the sell price. They think without a calculator. I don't care if you use one or not. Given the original price and the percent discount. You want to think about the formula when you work with percents. What you're actually doing is the percent that was paid times the regular or original price to equal the sell price. So when you're working with one that has a discount, what you want to do is use what's known as the complement of that. If I have a 30% discount, I actually ended up paying 70% of the full price, right? So an item is regularly priced at $40. Lamar bought it on sale at a discount of 30%. How much did he pay? Well, we're going to say he paid 70% of the full price or the original price. If we take 70% times 40, we get $28. So his sale price is $28. The price of an item has been reduced by 80%. If I reduced it by 80%, I only paid what percent? 20%. So I paid 20% of the original price of $90. 20% of 90 is 18. You got a pretty good deal if you only had to pay $18 on a $90 item. Now number 6, notice the wording on that one. An item on sale costs 45% of the original price. It's not a discount or a less. You'd use that 45%. The original price was $40, so what we're doing is just figuring out what is that 45% of our $40. What was it? 18 again? I don't know, I didn't multiply it out. Yep, that's what I'm getting, 18. 18 again. So be careful on there. If it's reduced, discount, less, off, all of those wordings we have to use the complement. But if it says of the original price, then I use that percentage that they have listed in the problem. When we do the next ones, basically we're just going backwards, or well, kind of going backwards anyway. A suit is on sale for 33% off. The sale price is $335. What is the regular price? So again, if I think about the formula, the percent that you paid times the regular price is equal to the sale price. My suit is on sale for 33% off. If I have a 33% discount, what percent did I pay? $100 minus 33 would give me 67. So I paid 67% of whatever the regular or original price was, and I ended up paying $335. If I want to solve that, I need to move this to the other side of my equation. The opposite of multiplying is dividing, right? So I end up having to divide the sell price by the percent paid. So my regular price or my full price of my item was $500. Seville, did you have the packet for one? Because I don't think there are any more on the counter. They all disappeared. Number 8, Charmaine bought a table on sale for $639. This price was 29% less than the original price. So again, we had a discount. If I had 29% less than 100%, I would have 71%. So 71% times my original price is equal to my sale price, which was the $639. That looks like a 0 instead of the original. And I'm going to divide by my 71%. And you said it was 900? So $900 is my original price. So on number 9, a sofa is on sale for $624, which is 64% of the regular price. What is the regular price? So what should I have for my equation? So I'm going to take my 64% of my regular price is $624, and then I just divide by my 64%. So $624 divided by 64% was $975. So $975 is my regular price. So if I have the sale price, I'm going to divide by the percent that I paid in order to find my original price. 10, 11, 12, again, finding simple interest without using your calculator, it says. I don't care if you use your calculator, but the formula for simple interest is that to get my interest, I'm taking the principal, the amount of money I invested, times my interest rate, times my time. On Alex, they'll do it in 2 steps and find the interest for 1 year, multiply it by the number of years. But since you're using a calculator, you might as well do it all at once. Bob deposited $500. That's my principal. Pays simple interest at 6% per year. 6% as a decimal is 0.06. And I'm going to do it for 5 years. So I'm going to take 500 times 6% times 5, and I would get $150, right? So Abdul deposits $6,000 into an account that pays simple interest at a rate of 4% per year. How much interest will he pay in the first 4 years? So on your calculator, you're going to do what? $6,000 times 4%, 0.04, times my 4 years. What did you get? $960? $960. So number 12, Bob deposits $800 into an account that pays simple interest at a rate of 10% per year. How much interest will he be paid in the first 3 years? So on your calculator, you're going to do what? 800 times 10%, 0.10 times 3. If I multiply that out, I get 240. I don't know if these other guys just don't want to talk or if you're too fast for them tonight. She's too fast. You're too fast. We gotta slow down. All right, these ones are a little tougher. Those first ones, hopefully, were all stuff that you remember doing from before, or at least didn't take you long to figure out. Sets A and E are given below. A is the set 1, 2, 3, 4, 6. E is the set 0, 2, 3, 8. Find the union of A and E. Find the intersection of A and E. Union. You're going to join the 2 sets together. So when you do the union, you're going to have one big long set. If something repeats, you only need it in your set once. So if I'm going to do the union of A and E, using set notation, I'm going to put my set symbols, and I'm just going to list all my numbers. I have 1, 2, 3, 4, 6, and then I've got a 0. I've already got the 2 in the list, I've already got the 3 in the list, but I'm missing the 8. Now in Alex, they'll rearrange them and put them in order, but you don't really need them in order unless you really want to put them in order, just so you have all your numbers in your set. Intersection. Where do those 2 sets overlap each other? What do they have in common? Well, if I look, they both have a 2 and they both have a 3. So the intersection of my 2 sets are just 2 and 3. So union, you're listing every number in both sets once. Intersection, only those numbers that are in both of your sets. And sometimes I use variables instead of numbers. So The sets H and G are given below. H is the set A, E, and I. G is the set B, G, and I. What is the intersection of H and G? What do they both have in common? They just both have an I. So we're going to use the set symbols, and in there, there's just an I. That's the only thing they have in common. The second one, find the union of H and G. So the union, I'm just making one big long set. So I would have I got more than that. I also have the I, right? The I is still in the list. So listing everything A, E, B, G, and the I is also included in that list. Number 15 says the set L and J are given below. L is the set -2, 3, 5, and 8. J is the set -3, 6, and 9. Find the union of L and J. So if I do the union of my two sets, I would have so I have every one of those numbers. Since nothing repeated, I had a -2, 3, 5, 8, -3, 6, and 9. All of the numbers are in that list. The intersection of L and J. There isn't one, right? There's nothing that they have in common. So if there's nothing that they have in common, you're not going to use the set symbols. You're just going to use the symbol here. Looks like a circle with a slash through it. It means the empty set. They don't have anything in common. So over on your choices to the right on the side where they have those tools, you'll see that symbol. And if they don't have an intersection, you're just going to click on that symbol there. And the last three are doing union and intersection of intervals. Here they said if it's empty, write that empty set symbol. The sets F and H are defined as follows. F is a set, and this is red, X, such that X is greater than 1. Just means that my variable is X and I'm applying the rule that X has to be greater than 1. If I put that on my number line, 0 somewhere in the middle, then I have 1, I'd have an open circle, and I'm going everything going that way, right? H is the set X such that X is less than or equal to 6. 1, 2, 3, 4, 5, 6. On 6 I'd have a filled in dot, and I'm going everything going this way. Then they want you to do the union and the intersection of your two sets. This is the symbol for union. Looks like a U. This is a symbol for intersection. So, if I do F-U-H, F union H, I want every number that is included in either one of my sets. Well, this set goes 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, and so on. This set goes 6, 5, 4, 3, 2, 1, 0, -1, -2, -3, -4, -5, and so on. And so what ends up happening is that I've shaded every number going to the right, I've shaded every number going to the left. I went from -infinity to +infinity. We did that interval notation thing. We said if we're doing infinity, it has to have a parenthesis. And so my answer is going to look like that. Now my intersection is where those things overlap, or what numbers they have in common. In this case, they had these numbers here in the middle in common, right? So it really started here with the 1 and went to here with the 6 that I didn't write down. So my interval is going to go from 1 to 6, but I have to use those brackets and parentheses we used before. I don't think that one's plugged in.
Oh, it is.
Try one of the end ones. If it had an open circle, we use the parenthesis because that meant we aren't exactly on that number. So the 1 is going to have a parenthesis. If it had the filled in dot, we use that bracket because that meant we do include that number. The 6 is included in both of our lists. Remember using those notations before? Parenthesis. Parenthesis means you're not on the number. The bracket means you are exactly on the number. So number 17 says the set B and C are defined below as follows. B is the set Y such that Y is less than or equal to 4. So if I have my number line, wherever 4 is, I'm less than or equal to the 4, so I have a filled in dot on the 4. I'm doing everything going to the left. C is the set Y such that Y is less than 9. Well, 9 would be over here somewhere. On 9, I'm going to have an open circle. And again, I'm doing everything to the left. This time they want you to do the intersection first. B intersection C. I think the intersection's easier to see anyway. When you're doing the intersection, you want to see where they overlap each other. Like up here, where we had both the green and the blue, they were overlapping here in the middle. So I want to look at my number line to figure out where do those two lines overlap each other, from where to where. From 4 down to negative infinity, but since we like to read from left to right, we're going to go from negative infinity to the 4. Infinity is going to have what beside it? What end mark? Nope. The parenthesis, because we can't ever be on infinity. So infinity always has a parenthesis on it. You never reach infinity. The 4 is going to have the bracket because we are equal to the 4. It had that filled in dot. When we're doing B union C, that's everything that's in either list. So anything that got shaded on your number line. Again, if you look from left to right, they're shading down here, and it's shaded all the way up to the 9. There's nothing shaded after the 9, right? So my union is going from the negative infinity to the 9. Negative infinity is going to have what end mark? Parenthesis. Infinity always has a parenthesis because you can't be on it. The 9 is going to have what kind of end mark? A parenthesis because it has that open circle there. I didn't quite make it to the 9, right? So think about intersection. Where do the two things overlap each other? Union. Anything that got shaded on my number line. So we had one where they crossed over in the middle, one where they both arrows pointed in the same direction, and the third one we got here, if my board won't go up very far, I'll just draw it up a little higher, says V is less than 3 for my set D. So wherever 3 is at, I'm going to have an open circle, and I'm going to shade everything to the left. C is the set that V is greater than or equal to 8. So wherever 8 is, I'm greater than or equal to the 8, so I have a filled in dot, and I'm doing everything this way. It wants me to do the union and then it wants me to do the intersection. But I'm going to do the intersection first because I think the intersection is easier. Where do those two things intersect each other? They don't, right? There's a hole in the middle of those two things. So my intersection is going to be like on that one where we listed the numbers and they didn't have anything in common. We use that empty set symbol. The union of my sets. I want to list all the things in both of my sets. Well, because there's a space in the middle, I have a set that goes from here to here, and then I have a second set that starts at 8 and goes to the other end. So I'm going to have two parts to my answer. Two parts of my graph got shaded. The first section went from negative infinity to 3, right? Negative infinity should have what end mark? Parenthesis. The 3 has what end mark? Has what one? Parenthesis. It's an open circle, has a parenthesis. That's one of the sections on my graph that got shaded. I'm going to join them with the union symbol, which is going to be one of your choices over on the right. Then I'm going to do my other set. My other set starts at 8 and goes to the end of my graph, which is positive infinity. The 8 is going to have what kind of end mark? Bracket. And infinity is going to have what kind of end mark? The parenthesis. So those are basically the three ways you're going to see them. Either where they overlap each other in the middle, where they got a hole in the middle like that one did, or where they're both going in the same direction. So at least you'll have kind of an example of each one, so when you're working on your pie chart, make sure you're looking at those and saying, okay, which one of these three does this look like after you have it drawn? Then your answer should look somewhat similar to the answers that look the same. All right. We'll go ahead and work till about 10 o'clock, and then we'll do the next page. If you've got those union and intersection ones, you might want to try those because those are probably